In the last video, we blindly chose a single feature to train our model and we got a score of 56.8%. In this video, I'm gonna add 2 more features and got a score of 73.3%. That is a 16.5% increase. And I'm gonna show you exactly how to do this. Not only that, I'm gonna show you how to use this magical library to help you understand your data better. And it's exactly what people use in a real world job. Are you ready? Let's go. All right, so before we go on talking about the 2 features that we're gonna add, I wanna kind of explain the 3 basic types of features you can have in a model. The first, you already know, it's called a categorical feature, and that was our home planet. You had Mars, Europa, and Earth. If your dataset column values look something like an enum, then most likely it's going to be a categorical feature. The second is a boolean feature, true or false, which is normalized to 0 or 1. And the third is called a continuous feature, which is just a number range which represents some meaningful relationship to each other. Think about something like height. What this means is that the 2 features we are going to add is a boolean feature and a continuous feature. Let's take a look at our dataset to see what we can choose. Look at all these fancy columns that we can choose from. I'm gonna save you the pain of looking through it yourself because I've already chosen 2 for you, and that is cryosleep and age. First, let's come up with a hypothesis. For cryosleep, if you are sleeping when an emergency happens, what are the chances that you'll survive? When you're all groggy and your brain's half asleep, are you really gonna be able to make split-second decisions? So our hypothesis is, if you are in cryosleep, you're probably gonna be transported. I'm gonna show you how to get a bit more confidence on this hypothesis in a minute, okay? For age, it's a bit more complicated. If, say, you're a baby, you're probably gonna need some help from anybody else. If you're a kid, you can run around, but you're probably not gonna have enough life experience to make the best decisions in an emergency. Now, if you're an adult, you have both the physical capability and enough life experience to make good decisions. And if you're old, sorry, but you're probably on your way out anyways. So our hypothesis for age is if you are really young or really old, you're probably gonna get transported. And if you are of a prime adult age, you're probably gonna survive. Let's go through the checklist for cryosleep. Number 1, what does the data look like? We print out the first few rows to kind of see what the values are. We see that indeed, cryosleep is a Boolean column made of false and true values. It's a little bit more skewed towards the false values, which is not good, not important for this video. We'll deal with it in the future. And number 2, we print out the missing values. There are about 217 rows with missing values for this column. Third thing on our checklist is, how do the value counts compare against our target? So we printed this out and it does give us the information that we need, but something's wrong. Isn't this super hard to read? Like, we got false, false, true, true, false, true, true, false. If you think hard enough, you'll figure it out because it's only 4 lines. But what if you have 20 lines? You're gonna have a bad time reading all of it. At least for me, I know that I would absolutely hate it. But what if I told you there was a better way? Introducing matplotlib and Seaborn. Let's pop back up to the top of the notebook. First, import matplotlib as PLT. Do the same for Seaborn as SNS. Matplotlib is your base visualization library. If you've seen any machine learning article or tutorial at all, there's a 99% chance the charts you saw uses matplotlib. And Seaborn is just a high-level library that makes your graphs look pretty. It's a bit optional. I like it, so I use it. Here's the magic. We move down a little bit to see this plot bar function. The main thing you need to know is that the input to this function is your data frame or data set, the column that you're interested in making a visualization for, and an optional target in case you want to split up your values into groups. The rest of the code is just setting up a generic chart, things like the title, the colors, and just data sorting. This stuff is a little bit cumbersome, so you can see why I put this into a function. I don't want to be writing this for 20 different columns. Let's see how this works. Let's go back down to a cryosleep analysis. We're going to go right here and we're going to run this function. Isn't this so much better to take a look at? Like, you don't even need to strain your eyes. You know exactly what the data looks like and how it relates to the target. And check it out, our hypothesis was correct. If you go down here to the transported legend, you can see that red is bad and blue is good. If you were sleeping, cryosleep true, you're gonna get transported. And if you were not sleeping, cryosleep false, you have more of this blue bar right here, so you're gonna survive. As an exercise, I suggest you try this out for home planet. Let's do our analysis for age. Remember our checklist. Number one, what are the values and how do they look like? Looks like these are floating point numbers, but they look more like integers to me, and there are a number of different people who are at these ages. Very nice. As we see, we can use this as a continuous feature. Number two, looks like there are 179 rows with missing values for this column. Number three, how do the values compare against the target? I have another chart for this. We can't use a plot bar that we had before because there's going to be like 100 different lines because people can live from say 0 to 100. What we actually need is a histogram plot. The thing about a histogram plot is that you can bin number ranges into a single group. The main setup of this entire graph is pretty much the same as plot bar. We pass in our data frame, the column that we want to visualize, and an optional target. And all this is just generic setting up of the chart. How does this look like? Let's run the function. Look at that, much more easy on the eyes. Look at this chart, not exactly as we hypothesized. We did hypothesize that if you were really young, you're probably not gonna make it. And this was correct, as you can see all the red here. And we also said that if you're of prime adult age, you're probably gonna survive, which we see over here, of which we were correct, seeing all the blue, but what we were wrong about are the old people. Turns out, if you're old, you probably have a lot of life experience, and depending on those experiences, you might survive, you might not. It's pretty much a toss-up here because we see red, blue, red, blue. Another thing that this graph helps you see is the skew in the data. We have a lot more people in this middle range here. When your data is imbalanced like this, it kind of forces your model to think a certain way. Now, there are techniques to solve against this, but we'll cover that in the future video. Anyway, I just wanted to show you how these visualizations here help you confirm your hypothesis and help you understand your data a little bit better. The technique of this whole thing is called exploratory data analysis, or EDA for short. EDA, it made my machine learning journey so much more fun and enjoyable. It wasn't just throwing random data into the model and seeing what I got. I actually had some sort of technique to look at the data and be like, huh, okay, we can do this or we can do that. I'll have a video dedicated completely to just EDA in the future, but for now, let's just add the two columns as features and see how the model performs. Same as before, we need to fill in some of the missing values for cryosleep with the value false. The reason for this is because if we look back up here with the cryosleep values, we see that there are more falses than true. So likely people are probably going to be not in cryosleep in this scenario. Going back down, we set our test data set with the same thing. We do something special here. We set this column as a boolean type. The reason for this is that sometimes when you import a CSV, it might interpret it as a string column, and then that's going to break TensorFlow when you train. And we do it after the fillnas because if you set the column as a bool, any null values are going to be turned into false or true. I don't know which one it is, but it is going to be changed to a false or a true, so you might as well get ahead of that and change it to whatever you want. For age, we are going to use the mean or average of the entire data set. If we take a look up here, we see that most people are within this middle range. So likely this mean value is going to be something in the mid 20s, maybe 25, 26. This isn't the best thing that you can do, but it is an okay thing to do to start off. My philosophy is make it work and then make it good. With our columns filled with data, let's build our features. We're going to define some new variables to make our lives easier, an inputs dictionary to keep track of our feature inputs, and an outputs array, which will keep track of our feature outputs. For cryosleep, we create an input layer like we did with home planet, except this time we changed the data type to tf.bool. We then cast the bool input to a float. The reason for this is because the model needs a numerical value. It doesn't take true and false well, so we have to cast it. For age, it's already a number and it's already a float, so there's nothing to do except just create this input layer and plug it into the model. For both of these features, we put it into the correct input dictionary with the key being their name, and we append it to the outputs array. Now that we have multiple inputs and outputs, how do we feed it into our model? We need to combine them into a single layer to feed it into the hidden layer. TensorFlow has a very useful component called a concatenation layer. This is why we have an outputs array here, because we can just plug it into the concatenation layer. To show you what's going on, here's a quick visualization. Our outputs variable now holds 3 of our feature outputs. Using the concatenation layer, we combine and flatten these into a single input. It then feeds into the hidden layer of our neural network with an output prediction of, once again, 0 to 1. We're going to refactor our code a little bit. We typically want to group up code that has the same function so that it's easier to control the flow when we want to update or change our features. So we're going to move these home planet filnas up here with the other ones. And then we're going to move our layer definition for home planet down with the other ones. All right, let's actually get to training. Let's bump up our epochs to 20, then add Krauss, sleep, and age into your training set. And we're ready for training. Let's go. So training's done, and what I don't like about these results is that the loss is not going down. We did start off with 0.7 and it kind of went down, stagnated over here. So I really got to figure this out. It's not good that this is happening. But anyway, let's run predictions and see how our test set does. The only difference here is that I added the Krauss, sleep, and age features to the prediction inputs. Let's run this. Okay, we're done. So let's save this to a submission.csv file and kind of take a look at the results. Very nice. We're at least getting different numbers than we did last time. I think last time, based on just home planet, we probably had 2 unique numbers for the results. Over here, you can see that based on the different combinations of home planet, Krauss, sleep, and age, we get a different prediction for each. Looking a little bit better, but there's definitely room to improve. Anyway, do the same thing. Open up this column over here and download the submission.csv file. Save it anywhere. Just remember where. I'm gonna name mine less than 3 just so we're clear on which file we're using. Over here, you can see the 56.8% that we had in the last video. And this is the 73.3% that I got when I was doing the code for this video. Click on submit prediction, go over to where you downloaded your submission CSV file. So you see over here, less than 3, drag it in, put in less than 3 model. Okay, I actually don't know what the result's gonna be. It could be good, it could be bad, we'll see. And submit. Nice, we actually did better than when I was preparing, 73.9%. I'd say that's pretty good for 3 columns. That's something like a 17% increase from 56.8. I'm pretty happy about that for this video. I hope you enjoyed that. There's still a lot more things that I wanna share in future videos. There's a lot more things I wanna teach you, but I hope that what you've learned in the last one and this one is really helpful and is actually kickstarting your machine learning journey. If this was helpful to you, help me out with the YouTube algorithm, like, subscribe, comment, do the usual stuff. And if you don't want to, that's okay. Anyway, that's all for now. Bye.